All right, I trust you did well on that quiz. Students in here didn't seem particularly confident, which is a bad sign, but maybe they did better than they thought. Or maybe they're just like, Georgia Bulldogs fans, and they are scared to express hope until after the game is over. And so, I don't know, maybe that's what it is. Like, no, I'm not even going to hope it's good until I actually get it back and find out I won. But anyway, let's go ahead and continue on. Now, I made reference a moment ago as we looked at some problems on the screen that we had that thing, sides were parallel, sides perpendicular. I said it's a rectangle. And Brandon had said square. I said maybe a square, but you'd have to know the sides are equal in order to know it's a square. And we don't know the lengths of the sides or the lengths of the segments. So we had to stop at rectangle. Well, that makes me think, how do we find the length of a line segment? How convenient that the next thing for you to put in your notes is finding the length of a line segment. And you can certainly abbreviate this, geometry survivors. Length of a line segment. If on the Cartesian plane I have 2 points, such as the points that we had named earlier that defined the quadrilaterals, well, obviously to find the length of a line segment, we could measure the distance from one end point to the other. In fact, in geometry, my geometry grads will remember, we measured with our compass, end point to end point. And that's how long the line was. We didn't care how many inches or centimeters it was that long. However, it was end point to end point. Well, literally the length of a line segment is defined as the distance between the endpoints. And again, you may abbreviate. Lucky geometry students. All right, distance between the endpoints. So let's take some examples here and see how we would find the distance between the endpoints of some of these line segments. Let's suppose, for instance, we had the point 3, 3, and we had the point negative 5, 3. Well, of course, one thing we could do certainly is get out a piece of graph paper, draw a quick Cartesian plane, since it's not graded, we're too lazy to put arrowheads and increments. But I could plot a point at 3, 3. I could put another point at negative 5, 3. Increments actually would have helped here. And I could say, okay, this line segment that goes between these 2 points, how long is it? And we could actually count. 1, 2, 3, 4, 5, 6, 7, 8. 8 units. A unit being the size of the square on the Cartesian plane. Okay, makes sense? It's about an inch, not quite, but about 8 units, 8 inches-ish, something like that. Questions on that? Easy enough? You just, how far apart is it? Count. Right? If we had, for instance, 2, negative 1, or if I had the point 2, negative 3. Okay, so I plot the point. 2, negative 1, and 2, negative 3. Okay, all of you can do this one easily enough. How long is the line? 2 units. Because you can count it, right? Very easily, okay? If we had negative 3, 2, and 1, 5, for instance. Okay, so negative 3, 2, and 1, 5. And all we have to do is count how many units. Well, wait a second. That's true. A horizontal or a vertical line would be easy to count. But when it's slanty like that, but if you go back in your minds, you two, to junior high, you three only have to go back to last year. If I were to, let me go with yellow here to show a little emphasis here. If I were to go across, so I'm right underneath this point, and if we're to go straight down, so I'm next to this point, I would form a little triangle. A little right triangle, correct? Yeah. And in a right triangle, you might remember from your junior high days this formula, c squared equals a squared plus b squared. Do you remember that? Pythagorean Theorem, right? And so if I said, well, I know that this right here has a length of 3. Yeah, there we go. Okay. And this right here has a length of 4. 1, 2, 3, 4. Okay. Then I could plug these two numbers in here. 3 squared plus 4 squared, and 3 squared, of course, is 4 squared is 9 and 16 is 25. So we can say that c squared is 25. Of course, that's an incomplete quadratic equation. I take the square root of both sides, and I can get that c is positive negative 5. Well, we can rule out the negative, but apparently, if I could take a piece of graph paper and line it up, I would get 1, 2, 3, 4, 5 units long for my line. And I could get my 5 units that way. So the Pythagorean theorem would help. The problem is, we as a general rule don't want to have to dig out the graph paper, right? There's got to be a better way. Well, think about what we did to get 3. All we did was find the rise from this point to this point. And to find the 4, all we did was find the run from that point to that point. The rise and the run were the legs of the right triangle. So that kind of ties slope back in here. We can find the length of a line segment using what I call the distance formula. D equals the square root, because let's face it, c squared is a squared plus b squared, but square is just the, c is just the square root of a squared plus b squared. But a might be, for instance, the run, the x2 minus x1 squared. And the b squared could be, for instance, the rise, the y2 minus y1 squared. So instead of making a fraction out of the slope, we would square the rise, square the run, add them, take the square root. And this is the next formula for you to memorize from this section. So we have the slope formula already. Right, m equals y2 minus y1 over x2 minus x. So now we have the distance formula, which is used to find the length of a line. Just square the rise, square the run, add, take the square root. Let's look at some examples here together. Write this down if you would, please. Let's suppose we have the point 3, 8, and suppose we have the point negative 1, 3. And I want to find, without graphing it, how far apart are these 2 points? Well, for starters, let's take the distance formula. Class, say it with me. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we plug in the numbers. Well, for my x2 minus x1, we can do some of this in our head, can't we? 8 minus, or x2, 3 minus negative 1. Can we do that in our head? 3 minus negative 1? 4, and then square it. 16, all right? And then y2 minus y1, or 8 minus 3 squared. Of course, 8 minus 3 squared is 25. So we're going to take the square root of 16 plus 25. Well, what is 16 plus 25? 41. So we end up taking the square root of 41. Well, that was my answer, square root of 41 units. Though if you have a calculator, go ahead and take the square root of 41. And let's get an approximate number. I'm thinking somewhere around like 6.4-ish.
Yeah.
What is it?
6.403.
6.4. Hey, that was really 6.403. So 6.4 units, approximately that. Okay, easy enough. Now, never mind. I'm not going to go there. Let's take a look at another one. Let's say, write these points down. We have the point negative 2, 1, and the point 3, 4. And I want to find the length of the line segment that goes between those 2 points. Well, to find the length of a line segment, class, we need to use which formula? The distance formula. And the distance formula is, say it with me, D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And so we plug in our numbers. How would I plug in my x2 minus x1 here? Kendall?
-2 plus 3.
Good. And how would we plug in the y2 minus y1? Maddie? What is negative 2, negative 3, class? But when you square a negative 5, what do you get? Not negative 25, just 25. Of course, 1 minus 4, class, negative 3, you square it, 9. What is 25 plus 9? So the distance between these 2 points is the square root of 34 units. If I could reduce it, I would, but that's not a reducible radical. But I'll also find an approximate value. I'm guessing something like 5.8, 5.9. What is the square root of 34? 5.83? Yeah, let's just say 5.8. 5.8 units. Questions on that? Questions on using the distance formula? Let's do one more, and then we'll be finished. Write this point down, if you would, please. 0, 7, and 3, 4. What is the distance formula, Maddie? Tell me how to plug in my numbers here, Genesis.
X2 is 0 minus 3 plus 7 minus 4 squared.
Tell me what to write for my simplified values. Subtract and square. Audrey?
Negative, well, 9. 9.
9 and 9, so we add that together, class, we get the square root of 18. But that is a reducible value. How would I factor an 18, class? 9 times 2. And I can pull out a... So I can say that my distance is 3 times the square root of 2. 45, 45, 90, right triangle. 3 times the square root of 2 units. Or, the easy way to do this, by the way, would be to just take the square root of 18. What is the square root of 18? 4.2. 4.2 units? Approximately 4.2 units. Questions on the distance formula? We're going to use it more in our next lesson. We'll practice a lot more in our next lesson as well. For tonight, you're going to practice with the distance formula as well, though. I want you to write the distance formula at the start of each problem. Just like you saw me do, start with the formula. It'll help you to memorize it. Page 157, 1 to 4. Page 157, 1 through 4. And page 168, 9 and 10. Page 168, 9 and 10. So page 157, 1 through 4, page 168, 9 and 10. Writing the formula each time. We'll take a look at your quizzes in our next lesson, and we'll also continue working on the distance formula. Have a wonderful rest of your day, and you are dismissed.